Okay, so find all the values of k for which this equation here has two distinct real roots. Okay, so what we need to do here is rearrange this quadratic so it's equal to 0. Okay, so I've got x squared plus 2kx. Well, if I take that minus 4x over, I become a plus 4x, and then plus the 9k then at the end, put that equal to 0. So you can see then I've grouped the x's together. Yeah, there's a 2kx here and there's a 4x there. You're actually then better putting it in brackets. The 2k plus 4, and then the x then plus 9k is 0. So we can see here now we've got a quadratic with a, b and c identifiable. So we can say a is equal to 1, the value in front of the x squared. B is equal to the value here in front of the x, which is 2k plus 4, and c then is my constant at the end, which is just the 9k there. Okay, so read the question, and it does say two distinct real roots. Okay, so given that we've got that, given two real and distinct, okay, so they're real roots but they're also distinct, they're also different, we can say that this is true. B squared minus 4ac is greater than 0. Okay, so what we'll do then is we'll substitute in these values. So we put 2k plus 4 in for b, and then we'll square it, take away 4 times a, which is 1, and then c then, which is 9k, and that is greater than 0. So we need to then expand this bracket here. And remember, this is a bracket squared, so it's a double bracket. And then we've got there 36k, haven't we, when we multiply 4 by 1 by 9. So if I expand that then, I'll get 4k squared plus then 8k, yeah, the outers, 8k the inners, so that's 16k combined, and then 16 at the last there when you expand the double bracket there. Take away 36k is greater than 0, and then we can bring those k's together, so it'll be minus 20k plus 16 is greater than 0. So we've got sort of a quadratic here now, which we're going to try and solve that quadratic inequality. But before we do that, just check each term to see if there's any common factors. And there is, isn't there? There's a common factor of 4. So we could break it down and divide by 4, which will make it easier for us then to factorize this. Okay? So you divide everything by 4, which is doable in this case. So now we've got to solve this inequality, okay, where this quadratic is greater than 0. To do that, we're going to focus on the critical points. Okay, so for the critical points, I'm going to look at where that quadratic is equal to 0. Okay. So where is equal to 0? Well, we can solve that quadratic, can't we? So we've got k minus 1 is equal to 0, or k minus 4 is equal to 0. So k will equal 1, or k will equal to 4. Okay, so that's the pair of brackets you've got there. Either of them is equal to 0, so that means we've got our results then for k. So those are the critical points, but we're interested when the inequality is positive. Okay, so if I was to draw the quadratic, one and 4, so turn it around, it's easier to draw the quadratic that way. So we're interested in where the quadratic inequality is positive. So where it's positive, of course, is above the axis here. Okay, the k-axis in this case, it's above it, isn't it? So the curve then above is in this region here, and it just keeps on going forever. So as long as k is greater than 4, yeah, essentially all the values of k greater than 4 produce positive graph, and it also produces positive graph here when k is less than this number. Any number less than this would be k is less than 1, or k is greater than 4. So you need to have that word or there, because you could be in either region there, okay? Not both at the same time. So k is less than 1 or k is greater than 4.